Today, we're diving into a really cool concept in experimental research, the between subjects factorial design. We're going to see how different variables can work together or against each other in some really fascinating ways.
I mean, seriously, think about it. The real world isn't simple, right? It's almost never just one thing that causes an outcome. So, how on earth do scientists actually juggle all that complexity in a single, controlled experiment?
Imagine you're taking a big exam. Is it just the noise from the hallway that's messing with your focus? Or is it also the fact that the room is, absolutely freezing? And here's the kicker. Does that noise become even more distracting because you're so cold? Answering that because question, well, that's exactly what this is all about. Okay, so here's our game plan. We'll start with this problem of having too many variables. Then I'll introduce you to the solution, factorial design. We'll break down the key ideas of main effects and interaction effects, learn the shorthand that researchers use, and finally look at what the results can actually tell us.
So how do researchers solve this puzzle of multiple variables working at once? Well, they have this incredibly elegant and powerful tool that gets right to the bottom of it. The official definition, straight from Myers and Hansen, is that a factorial design is when where you're manipulating more than one independent variable. But in plain English, it just means you're not just testing one thing. You're systematically testing 2, 3, maybe even more things, all inside one super efficient experiment.
And this really gets to the heart of why this design is so awesome. It's not just about saving time. It's about getting a picture that's closer to reality. You get to see the synergy, the way variables combine and work together, which is often way more insightful than just seeing how they act all on their own. Now, to really get a grip on how these designs work, we've got to learn the lingo. So let's break down the 3 key building blocks you're going to hear all the time. First up is factor. This is just a fancy name we use for an independent variable when it's inside a factorial design. So if we're studying noise and temperature, we have 2 factors, the noise factor and the temperature factor. It's as simple as that. Next, we have the main effect. This is the effect of one of those factors all by itself. We're basically asking a really straightforward question, like, overall, did the noise level have an impact on test scores, completely ignoring the temperature for a second? We're isolating it to see its individual power. And now for the really cool one, the interaction effect. Honestly, this is often the star of the show. An interaction happens when the effect of one factor is different depending on the level of the other factor. This is the it depends answer in research. Does noise hurt your performance? Well, it depends on the temperature. This is where the truly deep insights come from. Okay, that's enough definitions. Let's make this stuff concrete. We're going to use a practical example and follow it through for the next few minutes. So let's imagine we want to know how background music affects your ability to understand what you're reading. We have a hunch it's not just the type of music that matters, but also how loud it's playing. So boom, we have our 2 factors, music type and volume. This table shows you our whole design. Our first factor, music type, has 2 levels, light classical and hip-hop. Our second factor, volume, also has 2 levels, soft and loud. When you combine them, you get 4 unique experimental conditions. In a between subjects design like this, we'd randomly assign a different group of people to each of these 4 little boxes. So what questions can we answer now? Well, for the main effective music type, we'd average the scores for classical and compare that to the average for hip-hop, kind of ignoring the volume for a minute. But for the interaction effect, we ask that much more interesting question. Does the difference between classical and hip-hop change when the music is soft versus when it's loud? This is such a great question because once you can actually see an interaction on a graph, the whole concept just clicks into place. A chart can tell you almost instantly if you found one. Okay, let's look at some hypothetical data. In this first chart, I want you to notice the pattern of the bars. See how they have a similar slope? When the music is soft, comprehension is pretty good for both types. When it gets loud, both scores drop by about the same amount. This consistent pattern is the classic sign of no interaction. The 2 factors are just doing their own thing independently. But now, check this chart out. The pattern is completely different. The lines are not parallel at all. In fact, they cross. Here, soft classical music is great for comprehension, but soft hip-hop is terrible. And when it gets loud, the effect totally flips. This crisscross pattern is the smoking gun for an interaction. It tells you that the effective music type completely depends on the volume. Now that is a powerful real-world finding.
So now that you're an expert at spotting an interaction, let's learn the quick and easy way researchers talk about these designs. It's a really simple but effective shorthand. Our music study, the one with two factors that each have two levels, is called a 2x2 factorial design. That little bit of notation tells another researcher everything they need to know about the basic structure of your experiment.
In decoding it is super simple. It's a 3-step process. First, just count how many numbers are there. 2 by 2 has 2 numbers, so that means 2 factors. Second, the value of each number tells you how many levels that factor has. Finally, you just multiply them together. 2 times 2 gives you 4, the total number of conditions in the experiment. So a 3 by 2 design, that's 2 factors, one with 3 levels, one with 2, for a total of 6 conditions. See? Easy.
So when a researcher finally gets all their data back from one of these experiments, what are the different stories that data might be telling? The number of possible outcomes is what makes this whole design so incredibly informative.
You could find that only one of your factors actually mattered. Or maybe both of them mattered, but they didn't really interact with each other. Or, and this is usually the most exciting one, you might find that significant interaction, the one that tells that complex it depends story. And of course, sometimes you find out that nothing you tested had any real effect at all.
All right, let's sum it all up. The big things to remember are, factorial designs are for testing multiple factors at the same time. Their real power is that they can show you both main effects, the impact of a single variable, and interaction effects, which show how variables work together. An interaction is that key it depends moment. And finally, that shorthand notation is your secret decoder ring for understanding an experiment's structure at a glance. So I'll just leave you with this final thought to chew on. In the messy, complex world we all live in, which finding do you think is usually more insightful for a researcher? A clean, simple main effect, or a complicated interaction that might just be a little bit closer to reality? There's really no single right answer. Thanks so much for watching and keep exploring.